Good morning. So I finished up my CNC Plasma Cutter project and I posted a short 5-minute video summary, and I got some requests for a longer version with some more details. So here goes. I built this from scratch with some really good inspiration from a couple of places. Here's my finished product, and really the thing that got me moving on it was this project called JD's Garage. And these guys built this really simple, really elegant CNC plasma cutter. Looks a bit like the Langmuir product, but of course they have quite a few different changes, and they've made it two things. One, they made it really inexpensive. They say you can build it for $300, which I think is true. And the other thing is that you don't have to be an electrical engineer with a machine shop to do it, right? You know, all of the cutouts are you can do by hand, and you really anybody can create this thing. I was really inspired by the simplicity and the smartness of their design, so they got me moving. It also looks quite a bit like a product called the Langmuir Systems one, and you can see there's some differences. Langmuir uses lead screws, and JD's Garage uses belts, which are less expensive. Langmuir uses CNC anodized CNC aluminum. The JD's Garage uses printed plastic parts, which I use, but you know, relatively close cousins. And I was really inspired by the JD's Garage view. I had a little bit different vision. I wanted to actually put it underneath a workbench. You know, I do a lot of things in the shop, a lot of different kinds of projects, and I won't be using this plasma cutter very often. So when not in use, I wanted to stick away and be useful. So I made a workbench that I can use all the time on top of it. And then when I want to use it, I just take the top off and I have pretty good access. So I'll show you how that works. But my vision was a little bit different, and I'll show you in the end how close I got. First things first. I'm an engineer, so you know everything starts with the drawing, and you can see I'm bad at drawing, but this was my basic concept. And also I started in on the electronics, so you see I wanted to fit it roughly in a piece of paper, 8.5 by 11. I actually ended up with a little bit bigger box. You can see a 24-volt power supply. That's the big one on the right. A 5-volt one for the Arduino, and some other stuff on top, and then the Y servo, X and Z servos, and then Arduino Mega to control it. Here I am, so I fired up the milling machine, and here I am cutting the one of the plates for the Z axis. Another view of that, so you can see I'm cutting it out, and I actually followed the JD's Garage plans. I bought the plans, they were like $25. I really recommend getting them. I just can't say enough about the intelligence of their design. Another view, so I got that, there's the completed part. And then there's, you know, back to the electronics, I was kind of going back and forth. You see I've laid this out a little bit more. Again, that 24-volt power supply on the top for the motors, 5-volt on the left, the X, Y, and Z servo amplifiers, and the controller. It seemed like I kept adding stuff. Here are all the components for the Z axis. This is, you know, with basically a Z probe on the axis, which I really liked. Here's the finished product. And what happens is the plasma cutter attaches these two screws, the plasma head, and then you can see there's a limit switch, and when the head touches the metal, then it hits the limit switch, and you know where zero is. As with anything, you know, I ended up making, you know, especially the printed parts, like I swear 5 times each, right? I'd make a little mistake, or I didn't like something and I'd redo it. And so you can see there's just a ton of rework. You know, that's what happens when you do things for the first time on your own. You know, you think, you know, the cost of buying a completed product, or even something like the JD's Garage thing, you know, those guys spend a lot of time getting this right. And if you're going to do it yourself, you're going to do it over and over until you get it right, which is a part of the happiness for me of it, but you got to be prepared. You can see there's this pretty close to final. You can see I've got a relay there to turn on the plasma arc signal on and off. Also notice I use these DIN rails, DIN rails, and I found these really convenient. You know, this is a standard, and you know a lot of the terminal blocks snap into these. I just went on the internet Thingiverse and found a design of something that snaps in, and I think this actually does quite a nice job. And then I designed a whole bunch of different versions of this little purple thing, you know, one for each component that I had. I just would put a different, essentially, top on it and reprint it. Worked really well. Another view, starting to wire here, nearly done. You know, wiring takes a lot of stuff, right? You can see I've got my 3, 6, 9 spools of wire going to wire the servos into the Arduino, and it just gets more complicated from there. There's the first steppers are in. I actually, here I am soldering in the I don't know what they call I think they're called like aeronautical plugs or something like that. These round plugs that'll go outside of the box. Here is a nearly complete system. You can see I try to do my best to keep the wires neat and nice. It seems like I never do a good enough job. They're doing okay. Here's a look at the outside. You can see, so I've got these 6-pin connectors. I also got a 4-pin connector later on for the CNC Plasma. This is the X-axis that slides along a 2x2 square tubing. Another view of it 3D printed. Here's my cheap Lotus LTP 5500D plasma cutter. It's actually been working great. I actually have a Hypertherm with a high frequency start, which is not suitable for CNC because the high frequency messes with the electronics, but I gotta say, this thing has done really well. I did have a problem with the grounding wire. I was cutting some really thick stuff, and the wire got hot and caught fire. So it was obviously a low quality wire. I replaced it with like a number 4 piece of copper, and it's doing well. But in general, I've been super happy with this, especially for the price. You can see here's the aftermath of my wiring. Wiring is just messy, and there's a lot of stuff with all the crimps and the plugs and everything else is just what it takes. Here's a working system here, so you can see this is the Z-axis here, and I'll go up and down with the Z-axis. You see the electronics are beeping and moving. I've added some fans to the box, one pulls and one pushes to get some airflow going there. I'm using the Open Gerbil or Open Builds Gerbil controller, and here you can see it going up and down. Super happy with that, nice and smooth. Here is the big motor, the one on the right. This is for the Y-axis. You can see that moving around. There we go, working well. And then finally the X-axis, and that's going back and forth. So I got all the motors working. Now it's time to go to the bench. So I was going to use, this is the workbench that I had in the place where I'm going to put this, and I had an MDF top on it, and it's got like a quarter inch steel top, and I was going to rebuild this, and I decided that it was just not the right thing to do. I should just build my own bench completely from scratch, and so that's what I did. By the way, I first did ball screws, which I really like ball screws. There's no backlash, etc. I could not get the motors to move fast enough, and so I ended up having to go to a higher pitched lead screw. Lead screws are just fine. The belts are just fine. I probably should use belts in the first place. They were cheaper, but I ended up, I started with the ball screws. I'm actually upgrading the system from like an 8-bit low megahertz Arduino to an ESP32. It might actually make the system go fast enough where I can use the ball screws. I might think about moving back. I do like them. You can see here are here's the raw material for my frame. It was sitting in my dusty barn, and I've got these probably 6 10-foot pieces, so like 60 feet of 2x2 square tubing. And just like any engineer, I made a drawing and oops, go back. I made a drawing and a cut sheet, so you can see I made I designed it all on CAD. I use Fusion 360. It's a great product, and then I figured out I wanted to make the height exactly the height of the table saw next to it, so I could kind of use them together. So I had to stack all the tolerances, but ultimately I got my cut sheet, cut all the pieces, and started welding. So you can see there I'm doing one of the corners, and I got these nice jigs that keep everything nice and square. It takes a ton of pliers, but then you end up with a nice 90-degree corner everywhere. So there you go, and you can see in the final product I actually have one of these verticals open so that I can lean in there and also I can put in bigger pieces. I built it with them all together so it would be perfectly square, and then I removed it. Right, so you can see that's all. There's a a rectangle, which takes, I tell you, it takes a lot of trouble to get to an actual square rectangle in metal. Here I am. I'm cutting the wheel bases. These are 1/4-inch steel. And then what I did was I tapped those and welded them onto the bottom, and then I was able to screw the wheels in right there. And so you can see there I've removed that piece I had to build it, and I've got a nice frame to work from. Then I started adding the other pieces to it. You can see this is kind of the mock-up of the actual x-axis there. Here we go. Now I've built the base. And there it fits in the area that I have in my shop to fit it in, just barely, just how I wanted. And there's the water pan. So also another thing I did was I made it. Mostly you'll be cutting smaller stuff. The water pan easily accommodates a 2-foot by 2-foot square. But if I want to, I can remove the water pan and I can cut another 30-something inches. I think 32, 33 inches on the system. Here I am. I'm mocking up the x-axis. I guess maybe that's the y-axis, hard to say. Anyway, you can see here it is. I've got it all welded together, painted. I've got the 3D printed pieces on there. That's what the completed item looks like. And there it is. I've got it on a slider now, so that actually slides back and forth for the first time. That's the Y. And you can see here I'll move it. Nice and smooth. Works great. And then here I've put the x-axis on and then the z-axis. So these are all three axes and they all move. And I think I have a little video of me doing it. So you can see it moves back and forth, nice and smooth. So now I got a moving system with the motors. And here you can see the mount from a different view. And then I started measuring stuff, right? So again, I started with these nice ball screws, and I just started measuring, how does this go? I had to design essentially every part fresh, right? I got the JD's garage plans, and like I said, they're very good, and I really like them. I probably would have been better served to just use their drive belt system. I think it works really well, but I had it in my head I wanted to do it this other way, so I did it this other way, and you can see I'm trying to fit everything up, and then I start designing parts and put them in, and then they're wrong, and I have to do them again, and that's just what designing is. Here's the x-axis, getting ready to go, and measuring, make a drawing, print some parts. The parts are wrong. Print them again. Okay, they're right that time, and you can see it's just that's what engineering is. Here's the cross piece. I've got that painted. I painted that first, and here you can see the first time I'm moving the system. This is the x-axis moving back and forth. Really liked it. Just wasn't fast enough. And again, more measuring and looking. This is for the y-axis. I kind of clamped the motor in place and got that so that the x-axis could, or I guess it's the y-axis, could slide back and forth underneath the motor. And then I got that moving. I wanted to make sure it all fit. Then I printed more parts. And you can see, like on the left there's the y-axis motor mount, and I've got that all set up, and that actually worked pretty good. And so there's a mocked up system with all the pieces together, X, Y, and Z. There's again, I use these nice ball screws on the right, but I had to move to a higher pitched lead screw, which again works just fine. There's nothing wrong with it. Well more accurate than you need for a plasma cutter. Again, another drawing. Here I'm adding to the cart. So one of the things I realized while I was building it is it would be really neat to be able to store the sheet metal you want to use under the cart. That way I don't have to move it across the shop because stuff's heavy. And so you can see I made this little shelf here. It's just kind of leaning in place. It's not installed yet, but that's for 2 foot by 2 foot. And then on the very bottom you can put 2 foot by 4 foot. And I've actually got, I don't know, 1,000 pounds of steel there, and it's working just great. Now there's the completed and mounted all 3 axes. There's the system. It's kind of working, all together for the first time. You can see I've got my 2 shelves. So there's a shelf on the middle left there. That's for the 2x2s, and then the bottom is for the 4x2s. I've got the plasma cutter there. I've got an air regulator and dryer, and then I've got the electronics in a box there to the right. So everything's essentially in place here. Now it's time to finish it up. Another view is the other side. You can see the Lotus, and I have that on a little hook there, so I can just lift it out of there and use it, which I've done actually a number of times. For other projects, here's the motor drivers. I was trying to calibrate the motor drivers. You take pictures of where the dip switches are so you don't forget. So here's a view. So here's the first time I think I'm moving them all together, with the full system working. And you can see it's working just great. It's doing a little circle right there, but nice and smooth, working really well. This is my first cut, right? So I went in and I cut some S's. My last name is Salo, so I cut an S for Salo. And for the first view is actually pretty good, right? It was definitely some tuning in that needed to happen, but ultimately it was cutting and moving in the way it should, and I was super happy with it. Big step. There's my first cut product with it. You can see it's not a very good cut, but it cut it and it looks like an S, so I was calling it a victory. I got some more tips for the torch, and actually I've subsequently upgraded to a pencil type vertical torch. I like that a little bit better. I messed around with a number of different controllers and connectivity. I was hoping to use the Wi-Fi, the ESP32, to talk to the Arduino. It turns out that there's a project called Fluid NC, FLUIDNC, that just uses one of these $10 ESP32s, and so I ended up switching to that. But this was kind of an intermediate step. I was messing around. You can see there's a little Arduino and two ESP32s, and I was trying to make them talk. I did not succeed. By the way, one thing I did succeed with, and this is thanks to the JD Garage guys. I just love those guys. They were really done a great job. You can see this is a little Bluetooth module, and so I was able to hook that to the receive transmit lines. You can see RxTX here from the Arduino Mega, and then I was able to connect to it from a laptop and just make it look like a serial port. So that actually worked great, and I haven't had to have the computer hooked up to it the whole time I've been using it. So it's a relatively elegant solution. It works. It's just not as good as using these ESP32s in the top. One of the problems I found is I only had one limit switch, which was the Z for the touch off, and it just it was the circuit was too noisy while the plasma cutter was running, and it would trigger itself. So I made a really simple what's called debounce circuit, essentially a capacitor between ground and the signal, and then a pull-up resistor, so that you get it's essentially a low pass filter. I probably put 20 minutes into this design. I might take and make this a circuit board just to make it a little cleaner, but it's actually working just great. There you can see I'm dialing in the machine, and I've got a little 2x2 square with a circle, a rectangle, a hexagon, and an oval, just to see how it's doing. I had to do some soldering. There's one of my soldering kits. I got a video somewhere on making that. A little portable soldering kit. I needed to add something. I don't remember what it was. Here's a view of it actually cutting. So you can see this is cutting my test piece. This is 1/8 inch steel, and it just goes through it like nothing. Did a really great job. I'm really happy with it. So I found one problem, and I don't know how I did it, but ultimately when I was at full travel on one side, I was off by, I don't know, probably 3 or 4 millimeters, quite a bit. So I had to go and rebuild or remake this part here in the back and move it to the right a little bit so that it all lined up, but it turned out great. There you can see I'm ready to paint now. So this is the upside down frame that's all clean and ready to go. And there's all the junk. There's all the stuff that'll go back on it once it's painted. You can see it's painted upside down, and then I've painted it right side up. Use just good old Rust-Oleum gray, and there's the finished product. You can see another look at it, giving it a final coat, and there it is, right? So, and you can see the table goes here in the top, and then in the middle layer there's the 2x2 sheets, and the bottom is the 2x4. I'll show you that later. Then I've got the plasma cutter and the electronics and the air regulator installed. And then the other thing, I'll show you this in a bit, there's a pump here, and one of the other things I didn't like is to have water in the pan. I like the idea of having a water-based pan because, man, is it messy if you don't. It's even messy sort of with the water. But, again, I'm not going to be using it all the time, and so I wanted to be able to get rid of the water. And so what I did was I installed this pump. And then you can sort of see it back there. I have this fuel caddy. I'll show you a better view in a second. And I can basically fill it up and drain it with this pump down here on the right, and that makes it nice and dry when I'm not using it. So here it is with the pan installed. There I put in the top. Again, I wanted this to be a workbench when I'm not using it, so I used MDF. Fiberboard, there's the pan with water in it for the first time. And the top, so what I did was I put 2 layers of MDF, 3/4 inch MDF, and then that front area does not have a metal bar, so I put the bar on the tabletop, and I was actually quite worried about it not being strong enough. I glued it in there. This is wood glue for the MDF. I actually used like a PU glue, like a super strong epoxy. I painted this gray and glued it in there, but I was worried it still wouldn't be strong enough, so I put a couple of little tabs. You can see there's another view. I'm about to put it on. Here I am staining it. Here's my test tank powder. I don't know if this is the best stuff or not. Somebody let me know. Seems to be working fine. It's green. There it is. There's the painted thing all ready to go in. There's the PU glue that I used. There's the finished electronics. I think I added or subtracted something. It seems like I've pulled that thing off 5 times working on it to add some new feature that I thought I wanted. And then here's the electronics, and this is from the JD's Garage. I added a torch height controller from them, and again, great product. and really simple. And I'm actually happy to have the torch light controller. They say you don't need one if you have your system right, but I find that the metal warps and it just moves, and it's so much easier to have a torch light controller, and it's super simple to put in. So I installed the torch light controller. You see there's my pinout for my Arduino Mega. There's the final with the torch light controller there on the left. And just to give you a torch light controller, here's the Arduino Mega, which is the brain. Here's my little debounce circuit. This is the relay for the plasma cutter. This is the Bluetooth thing. This is the 5-volt supply for the Arduino. These are the Z, X, and Y servos, and then 24-volt power supply, a couple of fans. So it looks pretty busy, but there's ultimately not that much stuff there. So you can see there's the product with the top installed, and I don't have them here, but like underneath this one bar, like I said, that comes off at the top, I actually put a couple little tabs, and later I put like 1,000 pounds of steel on it. It didn't break, so I feel like it's perfectly solid. There it is, sticks in just where I wanted it to, is nice and even with the table saw that I built some years ago, just what I wanted. Here I am, I'm filling up the tank, so you can see I just got the hose hooked to that little pump, and it just takes about a minute or two to fill up. It's really easy. Another view. And then I'm like, okay, now I'm going to cut some steel, and so you can see here I am cutting steel into 2x4 sheets, and again I put all 1,000 pounds of steel that I bought on the top of that Workbench, and it didn't go anywhere. So I feel like that's a nice strong system. Here I'm moving it, hard to move. It was harder to move the smaller ones than the bigger ones, and there you go. There's 1,000 pounds of steel on the top. Doesn't look like 1,000 pounds, but it is. It's 980 or something, and it's not going anywhere. You can sort of see the little tabs that I've welded in there just to support that. Seems like it's plenty strong. Another view, and then I've moved the steel down, so I've got some 2x4 sheets, and then some 2x2s on top of those, and some 2x2s. So 4 different sizes of plate, and fits in just how I wanted. I'm actually upgrading, so once I got it moving, I'm like, hey, let's get a better controller. So here's an ESP32, and then this is an ESP32 based dial. It's called from a company called M5, and somebody did a product called the Fluid dial to go with Fluid MC, and I quite liked it. So there's my finished product. I added the curve slats so that it would, I think, be a better base for metal. It's actually working just great. And here I am filling it up again. And here's a bunch of test cuts that I made. You can see it's behaving itself pretty well at this point. And then here's a look. Here's a cut. So this is a cut for a big sign. I won't play the whole thing just to show you a little bit of it working. Every time it probes, I actually sped up the probing a little bit after a while. I had it slow just for testing, but yeah, it doesn't need to be as slow as that to move. But there it goes. It's doing a great job. Cuts away. It's been very reliable for me. Another view. This is a sign I made for a friend, Peak View Guest House, and here I'll zoom ahead a little bit and just show you. Here I am cutting. This is for a friend of mine's Airbnb, and it's got this beautiful view of Pikes Peak. And so I found a silhouette of actual Pikes Peak, and I'm cutting it out here. And this is one of the things you could just never do by hand. You've got to have a CNC machine to do this kind of work, and I was just super happy with the fidelity that it gives. So this is I think it's 10 or 12 gauge metal. It's about 1/10 of an inch thick, 90 thousandths. Goes through it like butter. So you can see there it is cutting. So works great, really neat. There it is, everything all tucked away, all my 1,000 pounds of steel down there at the bottom. Everything folds away neatly when I'm not using it. Here is my new controller, right? So I took the Fluid NC project, and I didn't like the pendant they had. Thought it was a bit clunky, so I designed my own, and then there's buttons on each side so that you can just hold it with one hand and then turn the dial with the other hand. And then there's the ESP32, and there's a little 4-conductor phone cable that I wired into the controller so that I could use that for the wired pendant. I also put magnets in the back so I could just stick it to the side of the thing as opposed to having to find some place to hang it. And again, final product. And another view, so I'm actually cutting quite a bit more complicated sign. This sign had something like 100 cuts on it, and it did it just great. There's the tank that I use to use. That pan takes 10 gallons of fluid if you fill the whole thing up, and I don't quite fill it up, but that's 10 gallons. So this is like, I don't know, 12 or 13 gallon tank. It's not that much bigger than you think. It looks way too big, but turns out it's probably 2/3 full or something like that. So that I'm really happy with that system. This is that shelf I made. So I had this is it's going to go outside, and there's like kind of two hammocks and this pole in the middle. And so actually, this is half of it, and then I have built exactly the mirror in the other half, and they bolt together. And I put all the holes in there so that if it rains and stuff, the water won't get trapped in the tray. It'll just fall out through the holes. It's just sort of holding drinks and snacks and stuff like that. Another view you can see, Peak View is the name of the place, so I built it with Peak View. Um, and here it is cutting out. Here I am cutting out the holes. And so, here was my original vision. I really liked and was inspired by the JD's Garage plans and the Langmuir product. And then, like I said, I wanted one that I could put underneath a workbench myself and have it a little more stowable. Be able to drain the table easily and store the raw materials with the product. And so that's what I designed, and here's what I built. So pretty close to the final vision. So super happy with it, and I hope you enjoyed the video.